Mastering the usage of generics in Java is a very important skill for every Java developer. In this video, I'm going to show you how you can use generics in your own Java project. So let's get right into coding.
So for the start, we will have a little look at this person entity. As you can see, in this person entity, we already have two attributes defined, an ID attribute and a name attribute. And as you can see, these two attributes have different data types. Name is of type string and ID is of type integer. Now, the generic type is a thing in Java that allows us to define a variable but not the concrete data type so far. So we can do that by writing, for example, private th and then add this generic type to our class declaration. We use brackets for that and then write t inside. And why have I chosen t in this situation? Well, by convention, we normally use a single letter for generic types, and T is also a very popular choice for that. But actually, you can call this uh, generic type whatever you want. So you could also call it H, for example, but this would, not be as the convention says. So we will choose T in this case. Now, now we can also generate getter and setter for this. And now we can create a new person object and use whatever data type we want for the age attribute. So let's go to our main method and create three persons. So let's create person 1, person 2, and person 3. And as you can see, the IDE is already complaining that we forgot something. Because as we defined a generic type for this class, we need to define the concrete data type when we instantiate the class. So for our first person, we are going to use integer for the age. For our second person, we will use string for the age. And for our third person, we are going to use a custom age class that looks like this. It just has one attribute that is of local date, and the toString method is overridden and will just say was born on the, and then print the local date that we assigned. As you can see, the IDE is still not happy because we also need to add empty brackets on this side of the statement. Now we can say person 1 set age 20, for example, person 2 dot set age, we can say 30 years old, and for person 3 we can set the age new age attribute and then give it a local date of, let's say, 2000 and the 1st of January. And as you can see, this just works fine. Now you are maybe wondering, why do we need to use this generic type? Can't we just use here object and then write anything inside that we want? We could actually do that, but it would come with a great disadvantage. Because as you can see, when we now go to our person 1 and call the getAge method, it will give us back an integer. If we go to the person 2, to the getAge method, it will give us back a string, and for person 3, it will get us back the age object. If we just use object over here, we will now see that when we call person.getAge, it will just also give us back an object. And we don't actually know what's inside the person object. So generic types will give us way more type safety than just using the age attribute. So let's just undo this again. And for the next step, we are going to write a method that will print the age of all of these persons. So we are going to write public static void, and then we say print age, and we will get and we will put a list of person inside this method. So we will say list. As you can see, list is already a class with a generic type in Java. We say list of person. And now, what do we put for the generic type? Well, to print the age, we do not really care what actual data type is behind the age attribute. So we can use the wildcard for that. The wildcard basically says a person with whatever data type of age. We say person list, and then we can just say person list dot for each, and then exactly that, system out println person dot get age. Now let's have a look. What else do we get? So which methods do we have on the get age? Well, not a lot of methods. These are the methods that all objects have, because as we have put absolutely no constraints on our generic data type so far, it could be anything. So the only thing that we know is it's some kind of object. Now let's call the method, let's say print age, and then say list of, and add all our persons into this list, and execute the method to see if it actually works. And as we can see, the ages got print correctly. Now once again, you could ask yourself, why do we have to use the wildcard here? Why can't we just say object? And again, we can see that this will not work, because a list of person of object is not the same like a list of person of integer or a list of person of string. So if we do not care about the actual generic type that was assigned, we need to use the wildcard. Okay, now let's do something. We have given whoever uses this person entity total freedom over the data type. But we do not want that. Let's say we want to put a constraint on this generic type. And we can do that by saying t extends, and then whatever class the generic type t should extend. So for example, we could say number, and then the age attribute inside this person class can be anything as long as it extends from the number class. And we can see on our main method that string and age do not fulfill this constraint so far, do not fulfill this constraint, but the integer, yes. So we could change these to double and big decimal, for example, because they also extend from the number class, and then set the age value accordingly. Okay, now what is the benefit of doing it like this? What do we get back? Well, before we saw that the age over here did not offer a lot of methods. How about now? Now we can see that it offers way more methods than before. So long value, int value, double value, byte value are methods that come actually from the number class. And we can use the number class now because the person entity, the generic type of the person entity, whatever it is, it will for sure extend from number. The next thing we can do now is we can not only assign a single generic type to a class, but we can assign as many as we want. So we need to choose a different name. We cannot say T again, but we can use, for example, K or P. And then we can add as many generic types to our person class as we want. Obviously, we also have to define these generic types on our main method then as well. But for now, let's just stick to a single generic type. And what you can also do is, while your generic type can only extend of a single class, it can implement several interfaces. So for example, we could say that our T generic type needs to extend number and also implement the serializable class. Fortunately, number already implements the serializable class, so our code will still work. Last but not least, you can also use generic types on methods and not only on classes. So let's write a method that converts any array into a list and do this in a type-safe way. For that we can say public static, then we have to define our generic type, then our return type list of t, then we will say convert to list, and it will get an array of t, and now we will say return arrays dot stream array, and then to list. So like this, we have a type safe method that converts any array of any data type to a list of the same data type. And we can just prove that by saying list of string list equals, and now convert to list, and then new string, and let's assign some values directly, A and B and C. And we can see that this just works. Okay, and that's already about it for the generic type. So the next time you will see a hash map of string and integer, for example, you will know exactly that this is a class that uses generic type, in this case key and value, and that you define them by using these brackets.
And that's it for that video. My next two videos are going to be about functional programming in Java and how to use the template pattern in Java to improve your code. In both of these videos, generics will play a big role again. So if you're interested in these, consider a subscription to this channel, and if you like the video, I would also really appreciate a like.